Okay, today we're going to look at the last two reaction types, and these, I want to say, like, these 5 aren't the only 5 types of reactions. There are some other types that fall within these categories, but we are going to look at these last 2. This should be review for you from last year, but if it's not, that's okay. Just pause, rewind, watch some of the other videos, whatever you need to do, okay? So again, here are the 5 types. We're going to look at single replacement and double replacement, also sometimes called single displacement and double displacement. They're the same thing, just a different name for it, so don't be alarmed if you see that. Okay, so we're going to start with a double replacement reaction. You have a hint here that it's 2 ionic compounds, but it's actually, I think, kind of easy if you write it out in the format that I'm about to show you, but you're really just going to trade ions to form 2 new ionic compounds. So this is the basic formula. AX plus BY yields AY plus BX. So we're going to either trade our cations or we're going to trade our anions. And here's an example. Magnesium oxide plus calcium sulfide yields magnesium sulfide plus calcium oxide. So I'm just switching. In this case, I'm just switching my anions. And here's a visual of it, just so you can see in terms of a particle drawing what that looks like. Okay, so I love this image here. This image is just going to help us in terms of how to keep track of the switch that's happening. So the first thing I want you to do is I want you to write every element as an ion. I'm going to put the positives on top here, and I'm going to put the negatives on the bottom here, and I'm just going to put them directly below the ionic compound that they are a part of, and then I'm just going to draw an arrow to crisscross them, and you can see here, so I'm drawing the arrow from silver down to chloride, and then I just I circle and cross my charges to get my new compound. So crisscross and simplify both sets of ions. So here we go. Here's an example that we're going to work through. So I have CaO and then NaCl. So I want to write every element as an ion. I'm going to put my positives on top and then my negatives. I know that calcium is in that second column, so I have Ca with a 2 plus, oxygen with a 2 minus, and then I have Na with a 1 plus, and Cl with a 1 minus. Excuse me. So again, I'm just going to write my anions underneath with their charges. Then I'm just going to cross. Right, so I have Na. Whoa, that's weird. Let's try again. Na with a 1 plus. I'm going to have O with a 2 minus. Right, and then I'm just going to circle and cross their charges. So I get Na2O, and on the other side, I have Ca with a 2 plus, and Cl with a 1 minus. I circle cross, and I get CaCl2. Now again, I always want to predict my products and then balance my equation. Notice that my equation is not balanced here, so whenever you are filling out the products for a reaction, you want to predict and then balance. Okay, so here's another one. I know that I have Sr with a 2 plus, Br with a 1 minus, Al with a 3 plus, P with a 3 minus. If you don't know where those numbers come from, be sure to go back and look at your periodic table. Right, and then I'm going to cross. So I'm just going to go ahead and put my charges up here. Sr 2 plus, P 3 minus, circle cross. So I get Sr 3 P 2 plus, I have Al 3 plus, and then Br minus. Oh, this should be a minus over here. Let's fix that. And I get AlBr3. 3. Again, predict and then balance. The same thing is true when you're doing polyatomic ions, so you can do this all in the same way. Oh, excuse me. I have K plus up here, and then PO4 3 minus. I have Ca 2 plus, F 1 minus, so I'm going to cross. We'll do the easy one, K plus, F minus, which becomes just KF, plus Ca 2 plus, PO4 3 minus. I don't know why it's doing that. Cross my charges here. Remember, I have Ca3, which is easy, but I have to put PO4 in parentheses and put a 2 on the outside. Oh, excuse me. So remember, predict your products and then balance. So we're going to do the single replacement reaction next. You can actually use that same format to do the single replacement reaction. If you want, you don't have to. So an ionic compound that has a cation or an anion replaced by another ion. We'll talk about activity series later in the year when we're looking at reactions, but this is the basic formula. I'm either replacing my cation, notice here I'm replacing my cation, or I'm replacing my anion. And the reason why I showed you the double replacement first is because if you set this single replacement reaction up in that same format, then it becomes very easy to figure out whether or not you're replacing your cation or your anion. So same deal here. Write every element as an ion. Oh, I have a cough. Draw a line to connect the lonely ion to its new bonding ion. And again, like if you just cross it, you'll see that one ends up alone. You want to circle your new lonely atom and then crisscross charges and simplify. When you are looking at your lonely atom, always check for your diatomics, right? Always check and make sure that your new lonely atom isn't a diatomic, or that if it is a diatomic that you're doing 2 of them. Okay, so let's try here. So I have Ca and then NaCl. So I'm going to write it out as an ion, so it's Ca2 plus. Notice I don't have an anion here, so I'm just going to leave that blank. Then I'm going to do Na1 plus and Cl1 minus. So if I cross them, notice, well, let's do Ca first. So I have Ca2 plus and Cl1 minus. All right, so I'll get a product of CaCl2. But notice that sodium crosses down to nothing here. That shows you that it's going to become my lonely ion. So I'm just going to leave it as Na. I lose that charge. My electrons transfer. That's called a redox reaction. We'll talk about that later in the year. But it is going to lose its charge there. So again, just sort of trust me. We'll explain it later. Let's do another one. So I have F2 and then Al2O3. So again, I want to write it as an ion. So fluorine's ion is F1 minus. Then I have Al with a 3 plus, oxygen with a 2 minus. I'm keeping the positives on top and the negatives on the bottom because that's the format we've been using. So then I cross. Right? So let's go ahead and do our new ionic compound. I have Al with a 3 plus, F with a 1 minus. So I cross my charges. And that becomes AlF3 plus oxygen becomes my lonely ion, or my lonely atom. So I'm going to put oxygen, and then I'm going to check, is it a diatomic? It is a diatomic, so I have to go ahead and make it O2. Okay. One more, I'll do aluminum. Aluminum as an ion is Al3 plus. And then I have potassium K1 plus and sulfide S2 minus. Cross them. I'm going to have Al with a 3 plus, sulfur with a 2 minus. That becomes Al2 H2S3, and then potassium is going to be the element that ends up by itself. Again, I'm going to lose its charge. It's not a diatomic, so it's not K2. So I predict my product, and then I go ahead and balance it. That's it. So it's not terribly difficult. If you are confused, watch the video again, or there are several other videos that I've included that can help you. If you do not know your common ions, I have attached a list of common ions. Again, like, you need to know them. So if you don't have them memorized from honors chemistry, that's fine. You will learn them a lot by repetition, a lot by use. But you need to sort of commit. Well, you don't need to sort of commit. You need to commit these to memory. So I've attached it for you if you need to print it off, or if you need to make yourself flashcards or make yourself a Quizlet, whatever you need to do. But the common ions are really imperative for you to know. So that's it, and I will see you guys next week. Okay.